Let's look at part 2 of our study guide. And this one is going to focus all on our factoring and on our solving by factoring. Okay? Now remember, with factoring, we have 5 things to look at. Okay? The first, always, we want to look for a GCF. Okay? No matter what, we need to look for a GCF. Okay? Then we look at the number of terms, and the number of terms is going to tell us which method we can do. Okay? So let's take a look here at number 20. Number 20. First, we look at a GCF between 9 and 49. Well, 49 is only divisible by 7. Can't divide 9 by 7. So there's no GCF. There's no X or Y that exists in both. So now we look at the number of terms. We have 2 terms. The only thing we can do with 2 terms, if this is possible, is difference of squares. So remember, 2 terms. We ask ourselves, is there a subtraction sign? Which there is. And then we say, okay, well, what do I square to get 9x squared? Well, I'm squaring a 3x. Okay, that helps. And then, what do I square to get 49y squared? A 7y. Okay, so we have the 2 things we need. We have the 3x, we have the 7y. And the difference of squares formula tells us that then what do we do with these? We have to add them together, 3x plus 7y. And we have to subtract them, 3x minus 7y. That's it, right? There's nothing else for us to do. There's nothing that I can factor out of here, nothing I can factor out of here. That's it. Okay. All right. Let's take a look here at number 21. Same type of deal. I need to look for a GCF. Well, I look at 64 and 16. And I think, okay, well, they're both even, so I can divide them at least by 2. But remember, you always want to check to see, is the smaller number a GCF? Can I divide 64 by 16? And the answer is yes, I can. It's 16 times 4. Okay, so I know that I have not a 4. Why am I thinking 4 here? Okay, but I have a 16 out in front. And then I also look and I see that I have y's in both of these. So I have a y to the 4th and a y to the 6th. So we take the smaller exponent, which is y to the 4th. Okay, so now we write what's left. And as I said, 16 times the 4 gives us the 64. And I don't need any more y's because y to the 4th is already taken out. The 16 is already taken out, but I need the subtraction. And I need 2 more y's left inside. So I have a y squared. Okay. Now, normally, if we factor out a GCF, we'd be like, all right, well, that's it. But we have to look at what's left inside. And inside our parentheses, we have 2 terms, a subtraction sign. What do I square to get a 4? I square 2. And what do I square to get y squared? I square y. Okay, so again, we have the same type of problem as we did right up here in number 20. All right, so we're going to take, again, the GCF is never going to move, so that 16 y to the 4th is going to stay. But now I take the 2 and the y, and I have to do 2 plus y and 2 minus y. Okay, so this one had 2 things in it for us to do. It had a GCF with the 16y to the 4th, and it had difference of squares. Okay? All right, let's take a look at another one that's similar to that. We take a look at number 22. Number 22, I again check for a GCF first, n to the 3rd, n squared, n. So every one of these terms has an n in it, so I'm going to factor out that n. So I've got an n out in front. That just means I have 1 less n inside for all of these terms. So the n to the 3rd becomes n squared. the negative 5n squared becomes just negative 5n, and the negative 50n just becomes negative 50. Okay? So now we look inside the parentheses, just like we did in number 21, and we have to say, okay, how many terms do I have? Okay, I have 3 terms, n squared, negative 5n, negative 50. So that tells me it's either a basic trinomial or a slip and slide trinomial. And where do we look in order to figure out which one we have? We look at the coefficient in front of the squared term, which in our case is a 1. And because it's a 1, that tells us that we have a basic trinomial. Basic trinomials are pretty simple because this is where we look at our multiplication and our addition. We say what two numbers multiply to the third term, negative 50, but add to the middle term, negative 5. Okay? So 50 we know is 25 and 2, 1 and 50, but it's also 5 and 10. And the only pair of numbers that give us the 5 that we need are the 5 and the 10. Okay, so we have 5 and 10. But remember, multiplying to get a negative, one of these numbers has to be negative. And because the addition is negative, that means that the bigger number has to be negative. So we have a positive 5 and a negative 10. And at this point, we're 95% of the way done with this problem. The GCF stays out in front, so the n stays there. But now I need to use this positive 5 and this negative 10. So we have an n plus 5, and we have an n minus 10. Okay? And because this problem just asks us to factor, that's all we do. We don't set equal to 0. We don't do anything like that. Okay? All right. Let's take a look at 2 more of these here. And then we will take a look at number 27, and then we'll go on to the solving. All right. So number 23. First, we look for a GCF. 4, 12, 25, 75. No GCF there, right? Can't divide 25 and 75 by 2 or by 4, okay? Then we look at number of terms. I have 4 terms. And remember, 4 terms, there's only one method to do, and that is grouping. So I'm going to group the first 2 terms together, and then the second 2 terms together, including whatever sign is on that third term right here. I'm going to look at the GCF between just the first 2, between 4x to the third and 12x squared. I have a GCF of 4x squared, and I'm left with an x plus 3. Okay. Then I look at my second 2 terms. I have a negative 25x and a negative 75. And remember, this sign here tells me what needs to go out in front. And between 25 and 75, I have a GCF of 25. What do I multiply negative 25 by to get negative 25x? I'm just missing the x. And negative 25 times a positive 3 to give us the negative 75. And we know we did grouping right when these 2 binomials are the exact same, that x plus 3, that x plus 3 in our case. All right, so remember, we take that x plus 3 out in front as our first factor, and then the other factor is going to be made up of the 4x squared that we already found, and the negative 25. Okay, not too bad, right? Well, if we actually take a look at what this says, if you look carefully, look at this term, 4x squared minus 25, 2 terms, subtraction sign. And now we know 4 is a perfect square, we know x squared is a perfect square, and we know 25 is a perfect square, so we're actually not done with this problem yet. Okay, this problem, I can actually keep going because I square a 2x and I'm squaring a 5. So the x plus 3 is going to stay. And then we have a 2x plus 5. And a 2x minus 5. Okay, and that is actually our fully factored form there. All right. Now, sometimes this will happen with grouping, with difference of squares, you know, not with trinomials, but really with grouping and difference of squares. You have to look at what you have remaining and say, well, is there anything else that I can do? All right, we have to ask ourselves that question. Okay. All right, last problem that I'm going to do here with you. Let's take a look at number 25. Okay, so number 25 here, we have 3 terms. There's no GCF because we have a 1, and our leading coefficient is 4. So because our leading coefficient is 4, which if we look at 22, the leading coefficient of 1, so it was a basic. Leading coefficient of 4, that tells me it's a slip and slide, so I have to do this multiplication first. So I have to multiply the 4 to the 14. So that gives me an m squared minus 1m, and then 4 times 14 gives us 56. So we have minus 56. Okay? Now we have a basic trinomial, so we deal with it in the same way that we did number 22. Okay, I'm going to put a line here so that we don't run into any problems. So we look at what 2 numbers multiply to negative 56, but add to negative 1. Well, there's only 2 numbers that are going to give us 56 that add to 1, and that's 8 and 7. So we have an 8 and a 7. And again, if we multiply to get a negative, one of these 2 numbers has to be negative, and this negative 1 tells us that the 8 has to be the negative number. Okay? So that gives us the m minus 8 and the m plus 7. All right? And you always, at this point, you want to think, well, did I multiply? Okay, in number 22, nope, we did not multiply. In number 25, yes, we did. We multiplied by 4. So remember, if you multiply, you have to divide. So we have to divide by 4. I'm going to write this down underneath here. We'll skip 27. We'll do that in class. So now I have my fractions. I have to reduce them. 8 over 4, we know, gives us 2. So that's an m minus 2. 7 over 4, it does not reduce. And this is the last step. We slide the 4 in front of the m to give us a 4m plus 7. And that is our fully factored form using our slip and slide method. Okay? All right. A couple more problems here. 28 through 30. All right? I'm going to do 2 of these with you. Only 2 of them. Okay? So let's take a look here. We're going to look at 29 and 30. Okay? Number 29. It says solve. Whenever we see the word solve, we know we're setting equal to 0. We know we're trying to get the 2 answers. Okay? So with number 29, we look for a GCF first between 4, 5, and 1. There's nothing. We have a trinomial with a leading coefficient bigger than 1. So again, it's a slip and slide, just like we did on the last one. Multiply the 4. Gives us x squared minus 5x plus 4. Okay. And again, we still have equals 0. All right, so now we're looking for what 2 numbers multiply to give us a positive 4, but add to give us a negative 5. And now we have the situation where we have the multiplication being positive, the addition being negative, and the only way that can happen is if both of these numbers are negative. And the only two numbers that that multiply to 4 but add to 5 are 4 and 1. So we have a -4 and a -1. So we can do x minus 4. We can do x minus 1. Still set it equal to 0. And because we multiplied the 4 at the beginning, we have to now divide the 4 here. Okay? So let's reduce our fractions. This gives us an x minus 1. This gives us, that's still 1 over 4. And I'm actually not going to change that to 4x minus 1. We're going to show you why here in a moment. The reason why is because I'm solving, right? I'm solving here, so I just need to set this equal to 0. If I was actually factoring, like we were doing here in number 25, yeah, then I would go through and slide that 4 over. But because I'm solving, now I can just split them up. And I can do x minus 1 equals 0, and I can do x minus 1/4 equals 0. And then we just get the opposite, right? If x minus 1 equals 0, then x is equal to positive 1. And if x minus 1/4 is equal to 0, then x is equal to positive 1/4. And all we need to do left is just write it in our curly braces. And we put the smaller number first, which is the 1/4, and then the 1. Okay? So there's our first one. And then our last problem that we're going to do here, and again, we can take a look at the other ones in class. We're going to take a look at number 30. Okay, so let's look at number 30 here. Well, with number 30, we want to solve, so it has to be set equal to 0 like 28 and 29. But number 30 is not set equal to 0, it's set equal to -40. So we need to move that -40 over to the other side by adding it. So we're going to add 40 onto both sides. So that gives us an x squared minus a 13x, and then plus 40, and now it's set equal to 0. Okay? So we have it set equal to 0, so we look at our factoring. And we say, all right, what two numbers are we multiplying to get 40 that we're adding to get -13? Because, well, it's a basic trinomial. So I'm looking for the two numbers that multiply to 40, but add to -13. Now 40, you could think of 40 and 1, that doesn't work. 20 and 2, that doesn't work. 4 and 10, that's closer, but still doesn't work. But the numbers that do work for us are 8 and 5. And again, because I'm multiplying to a positive but adding to a negative, both of these have to be negative. So we get x minus 8 and x minus 5 set equal to 0. I don't have to divide because I never did any multiplication. So all I have to do is just set them both to 0. If x minus 8 equals 0 and x minus 5 equals 0, I get their opposites. I get x is equal to positive 8 and x is equal to positive 5. So then we just write our curly braces. Positive 5 and positive 8. All right. So I suggest that you take a look at the other problems we didn't do. Number 19, I can tell you right now, that's just a GCF problem. Number 24, that looks like a GCF and then a basic trinomial. And then 26 looks like a GCF, then a slip and slide. And 27, I want you to take a look at that and see what you think you might want to do to answer number 27. Okay? And then same thing on 28, that looks like a GCF followed by a slip and slide. All right, so go through those, take a look at them, and then come ready to go on Monday or Tuesday, depending on which day I see you. All right, have a good rest of your weekend, guys.